the weight and balance calculations. As we can see here, I've got a picture of the weight and balance schematic for the SR20, 22, and 22 turbo series. And we see that the reference datum is located just ahead of the propeller spinner. It is in the POH, it specifically says that it is 100 inches from the firewall on the airplane. So this imaginary datum line is right up there, 100 inches from the firewall. Next we have station is a location in the fuselage given in terms of horizontal distance from the datum line. So for example, the firewall would be 100 inches from the datum line, and then our seats and baggage compartment would be considered different stations that could be loaded with people or baggage. Next we have arm. Arm is the horizontal distance, usually in inches, from the datum to a position or station in the aircraft. So our seats would be a given arm from the datum line, as well as, say, for example, the firewall being 100 inches, the arm is 100 inches. Next, we have the moment. So the moment is the measurement of the force a weighted object is applying to the aircraft. So for example, on like a seesaw, the farther out you are sitting, the more force is required to, say, offset your weight on the other side. There's also another unit of moment, it's the moment. So we use moment divided by 1,000 just to make calculations easier in terms of calculating the weight and balance, so we don't have huge numbers to be adding together. Last term here is going to be the CG limits. So as the center of gravity moves forward or backwards, it has to maintain within the CG limits, which would be a most forward and aft position that the aircraft can have its CG for a given weight. A couple other terms, we've got the basic empty weight. That is going to be the standard weight of the aircraft, including optional equipment and unusable fuel, oil, and so on. Next, we have unusable and usable fuel. So like we talked about with the fuel system, there is a small amount of unusable fuel in the fuel tanks just to allow for sediment and water to not be allowed into the fuel system. So for the SR20, we have a 56-gallon usable load of fuel and 2.5 gallons of unusable fuel. And for the SR22 and 22 turbo, there's a 92-gallon usable fuel load and 2.5-gallon unusable fuel load. Then we have useful load. That is the difference between basic weight and maximum takeoff weight. So that is the amount of weight that we can actually load the airplane with passengers, fuel, or cargo. Next, we have payload. So that is the combined weight of passengers, cargo, and fuel load. Next is the maximum ramp weight. It's the maximum certified weight for ground operations, whether that be taxi, run-up, or taxi or run-up. Then we have the maximum takeoff weight. That is the maximum certified weight for takeoff. Then maximum landing weight, maximum certified weight for landing. Now, the 20, 22, and 22 turbo do not have a maximum ramp weight or a maximum landing weight. It's all kind of held under the umbrella of the maximum takeoff weight. Now we have the maximum zero fuel weight, which is the maximum certified weight of the aircraft excluding the fuel load. Now the SR20 does not have a maximum zero fuel weight, whereas the 22 and 22 turbo do have a maximum zero fuel weight, which for the 22 and 22 turbo, 3,600 pounds being the maximum takeoff weight, and 3,400 pounds being the maximum zero fuel weight. Last up, we've got the standard weights. So our aircraft use 100 low lead for fuel, which is 6 pounds per gallon. Water would be 8.35 pounds per gallon, and oil being 7.5 pounds per gallon. So now we can talk about the effects on the performance of the aircraft. So a heavier gross weight will result in a higher rotation or approach speed, a longer takeoff or landing roll, a reduced climb and cruise performance, shorter range, and higher stall speed. That is because the airplane is required to, say, for the takeoff and landing roll, it's got to move a lot more weight. So as it gets heavier, that's puts more strain on the engine. So you're going to have a little bit longer of a runway to account for that. Now, some additional effects on performance when we're talking about CG position. The CG is typically built to be behind the center of lift, as we can see in the two pictures that I have here from the airplane flying handbook. So the center of gravity is located behind the center of lift so that the elevator produces a nose down force, so essentially creating downward lift on the tail to keep the tail down, whereas so aircraft are typically designed to have the CG forward of the center of lift so that the elevator is required to produce a tail down force to keep the nose up and so on. So as the CG starts to move backwards, that elevator is now producing a little bit less of a nose up force because the CG is getting closer to the center of lift. So if the CG is closer to the center of lift, there's a less of a moment, so there's less upward nose force required from the elevator. Now as the CG moves forward, there's going to be a heavier nose, which is going to require the elevator to produce more downward nose up force, and eventually you might end up to where there's not enough nose up force created by the elevator. Some additional characteristics of, say, an aft CG position be an increased cruise performance because, as we were saying before, as the CG moves slightly closer to the center of lift and aft, the elevator is required to produce less downward lift. Less lift equals less drag, so you're going to be able to cruise at a higher airspeed or at a lower power setting for a given airspeed. It's also going to be a lower stall speed, and it's going to be less maneuverable. It's going to be less maneuverable because the arm between the elevator and center of gravity is going to be somewhat shorter. So there's going to be less force that's being produced by the elevator about the CG. A forward CG position will give you a decreased cruise performance, higher stall speed, and will be more maneuverable because the elevator is going to be further away from the center of gravity. Now we'll start talking about calculating the weight and balance for our aircraft. So we're going to be using weight calculation for the 22 or 22 turbo. So this here is brought directly out of the SR series workbook, which can be found in the Cirrus approach portal. All of the weight and balance calculation information is going to be found in section 6 of the POH. So we can go into section 6. I've got some pictures here of some of the stuff in there. So we've got a 2,400 pound aircraft and a moment of 326.563, and that is moment divided by 1,000. Now our payload down here, we're going to have a pilot in the front seat and a front seat passenger, both weighing 160 pounds, and a rear passenger weighing 200 pounds and 130 pounds of baggage, and a full fuel load. So we'll first off go to here. This will be found in section 6 of the POH. We've got our loading chart and our loading graph here, as well as a nice little diagram that is in the POH to help us calculate the weight and balance. So we've got up here our basic empty weight, which was 2,400 pounds, and our basic empty weight moment of 326.563. Next, we're going to add up those front seat passengers. They both weighed 160, that's 320. So we put 320 in the weight section here. And then down in the loading graph, we can find in the loading chart, we can find 320. And we notice that the forward passenger, which is right next to that 320, is a 45.9 moment. So we can put 45.9 in there. And then we'll go ahead and calculate the rear seat passenger, who weighed 200 pounds. So it's going to be 200 pounds in the back. And then same thing with that 200 pound person in the back. We'll measure out the moment for him of 36.0. Then we'll go to the baggage area where there was 130 pounds. Now, if we notice here, there is no 130 pound position, but in the baggage row there is a 130 pound maximum with a little asterisk there. And it mentions that that 27.04 is the moment for a 130 pound load in the baggage compartment. Then we can add all those together, both the weight column and the moment column, and get our zero fuel condition weight and our zero fuel weight moment. Next up, we're going to be using a full fuel load. So what we talked about with the 22 turbo is going to be a 92 gallon useful load. So 92 gallons at 6 pounds per gallon is going to be 552 pounds. We can also see in the loading chart right there, there is the double asterisk with 92 useful gallons of fuel, and that being a moment of 85.5. Then we can add that to the zero fuel weight and get our ramp condition weight of 3602 with a moment of 521.023. Then it says here on the next thing, fuel for start, taxi, and run-up is normally 9 pounds at an average moment of 1394. And because we're using moment divided by 1,000, that'll be 1.394, who we got right here, minus 9 pounds and 1.394. And we can add or subtract 9 from 3602, and we'll get 3593 with a moment of 519.609. And we notice that, okay, 3593 is already just below our maximum takeoff weight, so we're good to go there. Next thing we need to do is verify that the moment is within limitations. So that'll be just a page after in the POH. There is the moment limits chart. So if we look on the left side there, there's the weight in pounds, and on the bottom, that'll be the moment. So we've got a takeoff weight of just below 3,600 and a moment of about just under 520. So we can draw some lines up from 520 and across from just below 3,600, and we see that that puts us right in the center of gravity envelope. Now, if we're flying with people that, say, John or Mike, when you and I fly together, we've already done the weight and balance together many times. There's also the helpful MFD tool on the airplane that we can also just quickly confirm that we're within the CG limits as well. Now, if you're, say, doing a flight where you're you already know that you're going to be very close to that either weight limit or the CG limit, it is a good idea to actually do it on the paper so that you can get everything sorted out before you actually get in the airplane and decide, and then realize that you're outside of the CG envelope. Does anyone have any questions?
So Aidan, I want to touch on something that we were talking about with weight. So when we're doing performance charts like we talked about last week, and then we're doing our weight and balance, and we see that we have 92 usable gallons in the SR22 and 22 turbo, but you might be overweight. How would you decide how much fuel to take off, but also how would that affect where the center of gravity is for the airplane? And would you want to plot that on the ground on the chart, or would you want to wait to get in the airplane on the MFD?
That kind of calculation would be something that you would want to do on the ground, so that you haven't started up the airplane, gone through that whole process just to find out that you're outside of your fuel, or sorry, your weight envelope. Now, the best way to figure out how much fuel you can use is subtracting your zero fuel weight from your maximum gross takeoff weight, and that will give you a solid number of, this is how many pounds of fuel that you can take, and that's an absolute maximum.
Right. And then, so we have the section 6 of the POH with our loading charts, and we can see how useful those are when it comes to doing our calculations, because if you've ever done one by hand on like a 172 or something like that, where you're multiplying everything with a calculator, adding it all up and then dividing it, you can see how much better the Cirrus charts are, but what are some of the functions such as like ForeFlight or Garmin Pilot where we can get the weight and balance on there for the Cirrus aircraft, and what information and where would we find that information to make sure that's set up properly?
So from my experience on the SR20 specifically, the ForeFlight profile for the SR20 G6 isn't set up correctly. So that is something that I noticed because it doesn't actually have it listed as a maximum gross takeoff weight of 3,150 pounds. It lists at 3,050 pounds. So sometimes those third-party apps such as ForeFlight and Garmin Pilot, you have to verify that the weight and balance section is filled out correctly before you can start trusting that to do your calculation for you.
Right.
Whereas with the one in the airplane, you already know that it's going to be set correctly because it was set by the manufacturer.
And then for our pilots who are still learning and possibly getting into the world of aircraft ownership, when they're doing these plans, obviously fuel is the one thing that you don't want to take less of if you don't have to. But if you're coming up on that max gross weight, I want to kind of touch on your thought process on how would you decide what you leave and what you don't leave if you're trying to sacrifice stuff other than fuel. And especially if you're flying with just two people, kind of how to load it in the airplane appropriately, because we sometimes want to put, if there's 130 pounds max in the back, you want to start putting some stuff in the passenger seats in the back, and how you kind of decide what goes where. That game of Tetris that we always have to play.
Yeah. So typically my first kind of train of thought would be, is this something that I can get easily at my destination? Like, for example, we'll say we're doing a trip to Big Bear. We're going 3 people and we're really close to max takeoff weight already. And we want to put, say, ski stuff in the back. If that ski stuff is something that I can easily rent at our location, it's much better to just rent it there rather than potentially exceeding our takeoff weights just because we wanted to bring our own equipment. Then starting to think of, okay, well, if we've got 130 pounds of the baggage compartment limit, starting to think about, okay, what could I put into the passenger seats? I would tend to put things such as backpacks, bags, things that are soft, so you're not, say, ruining your interior, versus things that could, say, scratch or damage the interior that you could put in the back baggage compartment a little bit more easily, so that you're not damaging the leather seating.
Right. And deciding what's important to take with you and what's important to get there. There's always another option. I know of a gentleman who I was with in the Civil Air Patrol who would go scuba diving down in the Keys every year, but he lived in Kansas City, and they would ship all of their equipment at the start of the season, fly the airplane down, and then ship it back. And he said it was just a lot more efficient than stopping more frequently to accommodate, all the tanks and whatnot. And something else to keep in mind for the weekend adventures, especially if you're going down to some place where the fishing's big, or if you're someone that's into that, you might be taking more stuff back with you than when you originally left. Especially if you take this airplane on like a fishing trip, you have to accommodate for the cooler, the ice, the weight of the fish, and everything like that. So you really need to do the weight and balance for the trip there, but also the trip back, and then redo the weight and balance for the trip back before you depart again, because the getting stuck at your destination because your airplane is going to be in an unfavorable CG or way overweight, you don't want to do that. So those are all things to consider, and having that skill of being able to do the weight and balance by hand, but also with the POH or the third-party apps is important, because it's going to be coming up on your flight reviews. When you do your check ride, you're always going to be dealing with weight and balance. So you need to make sure these skills are sharp. We, at the Civil Air Patrol, would make our pilots do the weight and balance every quarter. It would be amazing how many of them still struggle to do it by hand, even after they were flying for, 20, 30 years. So, and every airplane's different. The Cirrus aircraft has a favorable weight and balance. With the MFD, you always know what you're getting into. But if you transition to another airplane, you need to be really aware of what you're transitioning to, because other airplanes fly completely different and react differently to different loads on the airframe. So I think that this was a incredibly informative presentation that Aidan gave us. I wanted to thank him for putting together one and it really getting in depth and explaining how weight and balance changes the characteristics of the airplanes while they're flying, and how to, ensure while you're doing your Cirrus aircraft weight and balance that you're getting the right information. Next week we have on Tuesday, I'm giving a presentation on the Cirrus transition, where we're going to talk about transitioning Cirrus aircraft and what that goes into it. And then on Thursday, Nick is going to be giving a presentation on what to expect on your FAA check ride, which I think for our students at Palomar Aviation is going to be really valuable to get some insight on what to expect when you're going with the DP to get your private pilot's license. If anyone else has any questions or comments, we'd be more than happy to answer them. We have a couple minutes left. If not, I just wanted to thank everyone for their time. I really appreciate everyone supporting us at Palomar Aviation. We want to make sure our students are staying connected during this downturn with the whole epidemic that's going on. And we look forward to seeing everyone next Tuesday, same time, same place. And just to remind you one more time, not to be considered formal flight instruction. We just want to start the discussion. If you have any questions, we'd be more than happy to help you out. We can be connected at palomaraviation.com, or you can contact your local TCI or CSIP at your Cirrus Training Center. I just want to thank everyone for their time and have a wonderful day.
Great. Thanks, Aidan. Thanks, Brian.
Thank you.
No problem.
Yeah. Good seeing everyone.
Thanks, guys.